if you look at our operations, what is the process we need to follow? We turn on the pump, we selected the valve position, we took all the data, we changed the valve position, and we repeated the system for 5 times. Now the last set is saying that we need to change the venturi. So we have 3D printed different kinds of venturi with different D by D ratio. Actually the kind is same, but the D by D ratio is different. For now, I'm just showing you some venturis. You see here, this is the venturi where there is a D by D ratio is 0.45. Here you can see it is 0.55. It is 0.6. And then this one is 0.65. So what we will do for your data analysis, you can compare all of your data, like the data you got for 0.5, and then you can compare your data, whatever data you can get for any one of these. So we will give you the data for 0.45, 0.6, 0.55, or 0.65. So you just need to take one of the data, or whatever the data is assigned to your group, you can compare between these two. For example, the data, all of the group will receive the D by D ratio of 0.5. This data is common for all of them. This is your first set of data. The second set of data, you will get a D by D ratio. Right now I just put X mark. Like it can be, X can be 0.45, it can be 0.55, it can be 0.65, or whatever data you can get. You just compare the data between these two. This is the table for whatever ratio you are assigned to. So then you can compare this first table with the second table. I will just show you how we can take data with these D by D ratios other than 0.5. As you can see here, this is a D by D ratio of 0.45, which is little less than 0.5. So what we need to do, we need to change the venturi. How we can change it? We just need to change the inlet and outlet, meaning we just need to attach our pressure sensors in the venturi. So let's first remove this venturi from the system. So venturi has been removed, and we will change the pressure sensor. I remove the venturi which has a ratio of 0.5. I just attach a new venturi which has a ratio of 0.45. So we have to repeat the entire system whenever we change the venturi. So right now what I'm doing, I'm changing the valve position all the way to the open position you see here. Now I will start the pump. So as you can see here, whenever we have a venturi which has a D by D ratio less than 0.5, we can see that the fluid flow rate, you can see the fluid flow pattern right now. This pattern shows that it is a turbulent flow. It is not a laminar flow. So the difference between turbulent flow and the laminar flow is that in case of laminar flow, the fluid flows in layers and they don't mix with each other. But in case of turbulent flow, the fluid flows in a way that they mix with each other and fluid velocity goes increase. And in our Bernoulli's principle, our assumption is that the fluid flow rate should be, the fluid flow pattern should be laminar. So since we don't have any laminar flow in this case, we cannot work with this. So that is why none of you will get any data with a d by d ratio less than 0.5. You will receive a Venturi d by d ratio above or beyond 0.5. So let's stop the system and attach one more Venturi which has a d by d ratio more than 0.5. So what I'm doing right now, I'm just changing the Venturi. So I attached 0.45. Now I'm going to attach a Venturi which has a ratio of 0.55. Had some water inside, so we just remove those water and then I'm going to attach this Venturi, these pressure sensors here. Okay. Now I attach this Venturi in the system. Now let's see. So you can see here the system right now shows a laminar flow. So with this laminar flow, we can take that data and we can get our fluid flow rate. So we need to redo the whole system when this Venturi is attached. Let me just take one more set of data for you so that you can understand if we change the Venturi, what we can expect. So we just changed the Venturi and we need to take the data, the actual flow rate, 3. It's 2.75 seconds. And we can see that we have collected 510 milliliters. Now, for the second set of data, if we start 510 and with a time of about 2.75, so here we see 2.96. Okay, I need to make it a little bit bigger for you. It's 2.97 right now. So with this data, what we need to do, we need to calibrate the system. So we restart the software. We got 2.97 here. So now, in this case, before setting the start and set, we need to change the venturi diameter. As you know, this time we have a change in the venturi smaller d, like the bigger d is same, however, the smaller d has been changed. So we need to multiply this larger diameter with the ratio we have using here. So we are using 0.55. So if you multiply, let's see, I find my calculator here. So the inlet diameter is 17.60, and we multiply this with 0.55, we get 9.68. So we get 9.68 here. Okay, so we need to change it to 9.68. Yes, 9.68. Now we will turn on the pump. And then we hit start and then set. So once we hit the set, it should give us the data, and then we will take a picture. Yeah. And you see right now 22.1. So the power is 22.1, and then we have all the values. I just taken an image. Is 2.94. The venturi we got 2.92, and then pump DP we got 1.36. Then the valve DPI got 0.19, and the venturi got 4.75. So this is the first set of data for a D by D ratio of 0.55. So I just write here D by D ratio, which is 0.55. So similarly, we will change the venturi and then like 0.55 to 0.6 or 0.65, whatever venturi data we provide here, we need to change the venturi smaller diameter here in the software, and then we will record our data. After that, we'll change the valve position and we'll go for the second set of data. That's how we will develop our data table. So we will give you the data table, and then you will need to analyze the data and write your report. Thank you.